course, requires balancing parameters between the interaction between the reconstruction loss and adversarial loss. This figure shows the result of changing this rate with adversarial loss. A larger rate will give you further detail, but a very large rate introduces artifacts. Tuning this rate is very important because it may result in unstable results. Our goal in this paper is to relax such tricky tuning processes and achieving a generic and robust structure, thank you, for conditional adversarial nets. The main idea here is to decouple the interaction between the reconstruction loss and adversarial loss. More specifically, we want the error from these two losses to backpropagate through two different passes. The left figure here shows the traditional ED plus GAN structure where the two losses are coupled. And the right figure is what we proposed, and it shows the proposed decoupled version, which we call ED//GAN. In the new structure, there is an extra generator, G, that duplicates the decoder, and it's shown by the decoder here, DEC. Red and blue dash lines are showing the backpropagation path in the proposed network. They are disentangled compared to the original structure you see on the left. In this structure, the input is fed to the encoder, extracting a high-level feature, which is shown here by Z. Then the decoder and generator share these features to yield a blurry content image, shown here by IED, and the high-frequency detail, shown here by IG. The red and blue arrows indicate the backpropagation path for reconstruction loss and adversarial loss, respectively. The objective function here is the summation of the two losses without any weight parameter because the two losses are not coupled anymore here. This way, the weight tuning is relaxed and the structure is more generic. Another contribution in this paper is proposing a metric to evaluate image quality. To our best knowledge, there is no good metric for measuring how real the generated images are in an adversarial network. Diverting from providing absolute scores like existing works, we provide a relative score on whether one model is better than the another. The main idea here is to train a binary classifier using the real and fake samples from multiple models, shown here by G1 through Gn. During training, the output of D for real samples should approach 1, and that for the fake ones should approach 0. We assume that the rate of approaching 0 will vary depending on how close the fake samples are to the real ones. For example, as shown in the right figure here, there are two clusters of fake samples in the red and yellow denoting generated samples from two different models, and the blue circles are basically the real samples. During the training, the output of D from real or blue samples will increase toward 1, and the output of D for yellow and red samples will decrease towards 0. The difference here is that the yellow graph decreases faster because the yellow samples are further away from the real samples and so are easier to classify by D. Based on the decrease rate, we claim that the red samples are better or closer to real samples than the yellow ones. Here is the result of comparing the traditional and proposed structure with different weighting parameters. You see it in the table. Our model is generating stable results, while the traditional structure, its stability basically changes according to the weight that has been chosen. In the bottom left image here, we have modified the peaks-to-peaks structure to adapt it to the proposed structure. Comparing our result to the original peaks-to-peaks structure with different weighting settings, we get comparable result, and we have managed to relax the tedious parameter tuning process. Here's another example of modifying an existing work into the decoupled structure. Here we got even better results than the original algorithm that was using weight tuning. And in conclusion, we relaxed the weight tuning step in conditional adversarial nets by decoupling the reconstruction loss and adversarial loss in backpropagation step, achieving more stable results. Thank you.